We first look at cost and volume analysis. We have some formulas here which gives us the relationship between cost, revenue, and the volume of output. In other words, the production volume. We have fixed cost. Fixed cost is the usually the one-time investment upfront. For example, the machines, land we either rent or buy, a factory we build, and etc. Now, another cost is variable cost. For each unit, we have to purchase a raw material, and that's our cost. Also, we have to put in labor to produce it. We also have to run the machine. Then we probably have to pay for the electricity. Now, for each unit, we have a variable cost, and we call that V. So for a certain volume, we have the variable cost equals to quantity times the cost for each unit. So that's our variable cost. We have a total cost equals to fixed cost plus variable cost. That's our total cost for a certain period. And we have a total revenue, which is revenue per unit times the quantity. Okay, let's look at the examples. Now here's the example. We have a factory. The upfront investment, which is the fixed cost, equals to $6,000. For each unit, we can collect $7, which is the revenue. In order to produce each unit, we have to pay $2, which is the variable cost per unit. Now we want to know what is the total revenue when the volume equals to 1,000. We know total revenue equals to the revenue per unit times quantity. So revenue per unit is $7. Quantity is 1,000. 7 times 1,000 equals to 7,000. Now next we look at the variable cost when volume equals to 1,000. We know variable cost equals to quantity times variable cost per unit. Now we produce 1,000 units. Each unit we pay $2. So the total is $2,000. That is our variable cost. Next, what is the total cost when volume equals to 1,000? What is the total cost? We know total cost equals to fixed cost plus variable cost, which equals to 6,000 plus 2,000. 6,000 is the fixed cost. 2,000 here from our variable cost is 2,000. The total is $8,000. The last question probably is what we're really interested in. That is the net profit. We know net profit equals to total revenue minus total cost. Total revenue is $7,000. Total cost is $8,000. The net profit is a negative $1,000. That means this factory is losing $1,000 if they produce 1,000 products. Now we want to know when the factory can break even. In other words, at a certain volume, the total cost and total revenue will be equal. The net profit will be 0. In order to solve that, we have profit equals to 0. We also know profit equals to total revenue minus total cost. Okay, total revenue equals to revenue per unit times quantity. Total cost equals to fixed cost plus variable cost per unit times quantity. So we reorganize this part, we get this. And we set it equal to 0. Solve this. For Q, we get Q equals to FC over R minus V. Let me repeat. Solve this equation for Q. So we get this. So now it's time to practice our break-even point. We know that the break-even point has an equation here we just had, which is Q equals to FC over R minus V. Now, in this example, fixed cost equals to 6,000, revenue equals to 7, variable cost equals to 2. So we solve this, plug in these three numbers into this formula. We get 6,000 over 7 minus 2 equals to 1,200. That is our break-even point. At this point, the factory is not making money. It's not losing money either. Here's the in-class exercise.